Good morning, good afternoon, it's Anne here at morganmaths.com. So a short video here to help you recall the trig identities that you're going to need for A-level maths at year 13 at A2 level. There are lots of formulas that you are going to need to use in the exam, or you could be asked to use in the exam. Some are given into your formula book, so make sure that you're familiar with them. So for example, I've given you some here on the right hand side, your compound angles, so those are given to you. From the compound angles, you can find the formulas for your double angles, like the sine 2a, for example. However, I really recommend that you memorize your double angles formulas because they are very, very, very common. Then you've got just two to know from AS, the ones about tan x being sine x over cos x, and then sine squared x plus cos squared x equals 1. And then at A2, you need to know your reciprocal functions, your sec, cosec, and cot. Remember, you use the third letter of each of sec, cosec, and cot to memorize whether it's 1 over cos, 1 over sine, or 1 over tan x. And then finally, you have your two double angles formula. Now, there are another four that you are going to need to use. Do they need to be memorized? You can try to, and if your memory works really well, sure, go for it. Personally, I prefer to know how to find them because it's really, really quick. So the first two, you're going to start from your AS formula, but I really recommend that you start by writing cos x plus sine x equals 1. And then first of all, to find the next trig identity, you're going to start by dividing by cos sec x, cos squared x. And that gives you 1 plus sine squared x divided by cos squared x. You now have tan squared x. And then 1 divided by cos squared x is going to be your sec squared x. So a very important formula. That one is probably the one that comes up most when you are trying to rearrange trig equations or to prove trig identities. And the next one, of course, will be if instead you divide by sine squared x. And cos squared x divided by sine squared x is going to be cot squared x. Sine squared x divided by sine squared x is give you 1, and then 1 divided by sine squared x is going to be your cosec squared x. So this gives you an extra two identities that can be useful in exams. And then finally, the last two are linked to your double angles. They are part of your double angles formulas. And to find them, I recommend that you rewrite your AS cos squared x plus sine squared x equals 1, and it's going to become very clear now why I like to put cos squared x at the front. The next one that I'm going to use is the cos 2x. So it's got to be cos squared x minus sine squared x equals cos 2x. And you can probably see that those two are really very similar. If you add the two of them, what are you left with? 2 cos squared x, the sine squared x cancel each other, equals 1 plus cos 2x. This is used a lot, but especially if you need to integrate, for example, cos squared x, because the only way you can do that is actually by using this formula. So you can rewrite it as, watch out, don't lose the fact that it was 2 cos squared x. That's going to be a half of 1 plus cos 2x dx. And in the same way, you can go back again to these two equations, but instead of adding them, you subtract them. Cos squared x minus cos squared x, they cancel. Sine squared x minus negative sine 2x, so watch out your double negatives, you now have 2 sine squared x. And then 1 minus cos 2x. And here again, very, very useful if you need to integrate sine squared x. So either you memorize those four identities, or you need to be able to find them quick. But what's important is speed. So make sure that if you've decided that you're going to find them fast, practice. You need to write all of them. You should be able to write all of the key identities, I would say in less than a minute. On here, on this second slide, I've just thrown a few exam questions where you're going to need to use some of these trig identities in different contexts. So I've picked up some OCR, some Excel, some AQA question, and then finally I've also added the integral of sine squared x dx, which does come up a lot. Well, I hope you found this video useful. If you need any more information or if you would like to get in touch, feel free to visit my website www.morganmaths.com. Have a good day!